Florence, yeah. Okay, great. That's fine. Seems fine. Okay, I think everybody was just finishing up pizza, and then we'll get started. The stream is behind.
Okay.
That's okay. I have my notes up there.
Okay. Oh yeah, I need to set it up in displays. Do you know how to do the displays?
Oh, so are you gonna mirror, or are you gonna
I was just planning on having this.
having one?
Yeah, having one.
Oh, I see. Okay, maybe hit arrange. Nope, that's not it. Somewhere in here. Oh, you know what? Didn't they change it to be up here or something? No, that's the camera. Let me scroll down here, see if it's. They keep feeling like they changed this. No, it's not it. They used to have a thing where it was just like mirror displays. You could Google it.
Extended.
Oh, mirror. Yeah, so now they're the same.
Okay. Oh, cool.
Yeah, and what you see there is what's up there. So I think
Right.
they're all the same now. So yeah, should we just? Yeah, quitting Discord's probably fine. I can monitor it.
Yeah, it's.
Although you need my PDF talk eventually.
Oh yeah.
Got to download that thing. I have my notes. I was thinking I wasn't going to give it, so the notes are, I wrote them down, but I don't have them in a document yet. So I'll
Okay.
while I'm streaming the thing. That's okay. I'll have it.
That part.
All right. I'm going to just get started with introductions. Those people can file in whenever they're there.
Yep.
Should we do it?
Sure.
You take the laptop away? You can read it.
No, I was going to turn it around though.
Okay. Yeah, well, that's fine. Okay.
Let's see.
This one. There we go. You want to turn it around so people can see?
Yeah.
Our sparsely. Oh, it cut out. Oh, it came back. That's fine. All right.
Yeah.
We just did this so you guys could see us.
Lit up the candles.
Yeah.
It's,
It's a little tilted, but
all right. So.
I'll have to sit this way.
Yeah. Well, I guess we'll get started and then we'll go from there. Yeah, it is all J's up there. You're right. You're at the San Diego Python meetup. Thank you for coming. I want to thank Qualcomm for having us, and I want to thank Jeremy, who wrangles all the speakers so we have good talks. And I want to thank Neo4j. Neo4j provided the pizza for the meetup. Neo4j provides a graph database that for certain types of operations is orders of magnitude faster than traditional relational databases. You can download it yourself, or you can run a managed version in the cloud of your choice. There's also a giveaway that you can scan the QR code. It's up on the door, and they are giving away a drone. They don't give it away just to San Diego Python meetup people. It's to all the meetups that they sponsor, but they give away a drone every month. So awesome. You should check it out and scan the code and get a drone, maybe. And yeah, everybody wants a drone. That's, yeah, I don't know. Worth coming for the meetup with the drone and the pizza. You like drones? You like pizza? That's all right. I also want to just do an announcement that the Saturday meetup, that one is 10 a.m. It's on Saturdays. It's online, so it meets through Discord. You can get all the info on the meetup page, or if you're on the website, sandiegopython.org, you can join the Discord from there. And it's a little bit different than this meetup in that it doesn't have lined up speakers. It's people chatting, it's people working on projects, but there's not like a speaker lineup or things like that. So you should check it out. It's a free for all, but it's Saturday, 10 a.m. Bunch of local developers. So if that's something you're looking for, check it out.
Not necessarily local.
Some of them are not local. You're right. We have people who used to be local and stuck with our group, I feel, and then a couple other people. As I mentioned, our website, sandiegopython.org. If you want to get involved on the website, and there's going to be a talk about that website today, all the code is available on GitHub. And there are people on Discord who are happy to help you if you want to add features to the website. Mostly those people are me, but there are other people too. The website, sandiegopython.org, has a link to our YouTube channel where this meetup and all of our meetups are recorded and streamed. And it has a link to our Discord, which is where people ask questions of local developers and stuff like that. There is a jobs channel on the Discord, which is an important thing because, you could look around this room, there's like 15 people in the room. And but if you post it in the jobs channel, there's hundreds of people in the Discord. And so, probably a better way to promote your job than the jobs channel. However, since there is a live stream and there is, I know there's at least one person who wanted to promote a job in the room. So Danielle, did you want to say a few words about your thing? Do you want to come up or you can say it there, either one? Well, this is not doing the recording. This is actually speakers. So, yeah. Yeah. If you want to speak, yeah, it's up to you. But I know you had a job that you wanted to promote, and so you should say your few words.
Thank you. Just a couple words. Hi, everybody. I'm Danielle Raleigh. I am CEO of a startup called BizProfi, B as in boy, I-Z, P as in Paul, R-O-F-I. And it's an educational technology startup. We're getting traction, and we are looking for a head of engineering to build out our AI strategy. So we've got an AI strategy. We know what we want to do. We've got a mentor, an advisor who's showing us how to do it. And our investors are telling me, Danielle, find someone who has AI experience and we'll give you some money. So I need someone as soon as possible. So yeah, if anybody here is interested, or if you know somebody who might be interested, I am Danielle, D-A-N-I-E-L-L-E, at bizprofi.com. So Danielle at bizprofi.com. Yes, sir. Question?
No, so I just messaged they had someone. Oh.
Woo-hoo!
Oh, well, we'll look at that later. But yeah, awesome. Thank you.
Thank you, everybody.
I do have a question.
Yes, sir.
Can you be more detailed as to what the AI strategy looks like? How is that going to be applied to your
Yeah.
platform?
So, I forgot to tell you what we do. So, BizProfi helps organizations to assess business communication skills. And this is our 4th app. And basically, it started years and years ago with me doing business communication skills training. And now what we're trying to do is all HR managers and managers are trying to assess communication skills because they say communication skills is the #1 skill that they're looking for. And as HRs and as companies move towards skills-based hiring, being able to assess those communication skills is like the holy grail right now. And I've been playing in this field for my whole career. And so what we're going to do is we're going to right now I can assess communication skills quantitatively, and then I have someone else who can do it qualitatively, which is the easier way. But now we can bring in AI several different ways. My investors told me they want to build one AI brain so that all of our data and all the processing is right there. But I already have the quantitative assessments working. We've got traction because we have a patent for dynamic badges. So maybe you've seen digital badges, like when you complete a course on Pluralsight or somewhere, you've seen a digital badge or I call those static badges. And those are old-fashioned. We have dynamic badges. We have the trademark and the patent for it so that our badges change color depending on the level of skill ability. So the darker the color, the greater your skill ability. But what's innovative about it, because that's like a heat map, Danielle, what's innovative about it is that our badges lose color if you don't come back in and practice the skill.
Oh, I see.
And that's the algorithm that we have already too. So,
Can I ask a follow-up question?
Sure.
Real quick though.
Okay, yeah. I guess what you're trying to do is create a vectorized database in which you upload all the data about efficient professional communication. And within that, you want to use specialized models, maybe fine tune, maybe enforced learning, and then be able to extract and assess the communication and automate the process of assessment. Is that what you're trying to do?
Yeah, in 3 levels right now, in 3 levels. Yeah, and like I said, we have an advisor who's doing that already, and he showed me how he's doing it in AI, and he's pulling it in from ChatGPT and different things, the language, and so we can build the exercises, generate those on demand. So there's 3 different ways we're going to build AI in. So yeah, so thanks for asking.
You guys should chat, and I know Jeremy, somebody on the Jacob wanted to chat as well. So, well, yeah, we'll chat offline, I suppose. You have interest. There are people interested, or at least people worth talking to. Awesome. I did want to go through a couple other announcements. The 4th Thursday of this month, which would be our normal meetup time, is too close to the holidays. So we will not be meeting on the 4th Thursday. We'll be meeting on the 3rd Thursday, and we'll be meeting at Regent's Pizzeria. There will be no talk scheduled, but there will be pizza there scheduled. So if you want to come to Regent's Pizza. All the info will be on the meetup page. So I haven't updated it yet, but we'll update it. So it'll be at Regent's Pizza in UTC. Awesome. Couple upcoming conferences. PyLadies Conference is coming up. It's December 6th to 8th. You can check it out, conference.pyladies.com. This is like the largest conference for ladies in Python. It is, I think they're doing it all online this year. So you can check it out, and yeah. And then also, I know this one's a little ways away, but tickets are starting to be on sale anyway. PyCon.us or PyCon.us, which you can find if you go to like pycon.org, and from there you can get there. It's in May 14th to 22nd. Pretty sure it's in Pittsburgh next year. But basically, they always do early bird tickets, and then the tickets get more expensive and stuff like that. So, if you want to go to PyCon, the time to start thinking about that is soon. So, yeah, awesome. It's always a huge conference, usually a couple thousand people. So, really awesome. The other announcement the last announcement before I get to speakers is that you too can be a speaker. So you can sign up to be a speaker on the website, sandiegopython.org. There's a link. You can sign up. I'm going to make the button to sign up to be a speaker really big. Really big. Because Jeremy and I are really motivated to line up speakers, because when there are not speakers, Jeremy and I become the speakers. And that is what has happened tonight. So Jeremy and I will be speaking tonight. Not exclusively, but in addition to other people. We also had some late cancellations. That's part of why it happened. But please sign up to be a speaker. We're always looking for talks at all skill levels. Whether you want to talk about the issues you had setting up your Python environment, you want to talk about something advanced with NumPy, you've built an optimization into NumPy. I want to hear both of those talks. I want to hear any talk in between. So, please sign up to be a speaker. They only have to be 7 minutes. If you want to go longer than that, let us know. But that is that. Cool. I think we're going to dive right into talks. We have 2 remote talks and then 2 in-person talks. Right, Jeremy? All right. Johann West is our first speaker, and Johann is going to talk to us about PureML, enhancing ML datasets with AI to create better ML models. Jeremy, you want to help get things set up, and I'll get the live stream set up, and then we'll go with it. All right.
Sorry about this. Switch you here.
Good, Jeremy.
Got to switch you here. Let's see. Do the whole. Let's see. Load this whole page. No. Not now. Come on. Is this it? End screen for myself, for everyone. No. Aha. Here we go. Better? All right, everybody can see you on the screen behind you.
All right.
So,
Ready to share my screen?
yeah, all set.
Everybody see this okay?
It's coming up.
There we go.
Good? All right. Hey, everybody. Thanks for coming out. My name is Johann West, and I'm one of the co-founders of PureML. This is one of my other co-founders, Suj.
Hey, my name is Sujin Rachuri, also co-founder of PureML. By day, I work at Oracle as a product manager, where I've been working on launching AI agents in the Oracle Cloud over the past 7-8 months.
And I am a machine learning engineer by day, and we've been working on this product, PureML. PureML is essentially AI to handle your dataset pre-processing. And so if you're not familiar with machine learning, dataset pre-processing is essentially a large portion of the process, which is doing things like data cleaning, like data consolidation, feature engineering, all those things that you have to do once you've collected your data before you can train a machine learning model. And that's what we're looking to handle with AI. And so what we want PureML to provide is, if we can get AI to handle all of this, that's going to provide huge benefit to people doing ML. So like companies, data scientists, machine learning engineers, all those people are going to save so much time because they won't have to do what dataset pre-processing, which is a huge portion of the process. And also, it's also going to like kind of tear down the barrier to machine learning for companies as we remove the need to dedicate so much resources and so much time to doing this dataset pre-processing. And so without further ado, we'll dive into the demo. And so again, this is an early stage rendition of our product. We're looking to go live sometime early January, but right now we're going to show off a couple features in this demo. So the data set we're going to be using today that we're going to run through is a data set of vehicles. So let me get loaded in. So as you see here, we have a data set of vehicles. We've got features like brand, model, mileage, fuel type. And also, if you're not familiar with machine learning, features are essentially columns in your data set. So if you have a tabular data set, you're training an ML model on, those columns are your features. So we have all these vehicles here. And next step we're going to do is just configure the ML problem type. And so our prediction target is going to be brand here. So from all these columns, we're going to try to predict the, price. We're going to try to predict the price of each vehicle. So that's going to be your target variable, and that makes it a regression problem. R squared XGBoost for the evaluation metric and training framework. We'll stick with that. And the first of the three features we're going to be showing off today is null or missing value handling. And so in every data set, you're going to have tons of null values. This is just a fact of life when you're doing ML. And so as you can see here, we've got a couple of null values here. So for brand, we have 2 null values in rows 1 and 2. And so usually what you might do for data set pre-processing is you'll just use kind of a dumb imputation method, we would like to call it here, which is like putting in an average, a mean, a mode, a median, something like that in order to fill this to handle your null values before you pass it off to your ML framework. And we think like we can use AI to do this better. And so what we do here is we look at the row context that we're provided, and we use the AI agent's intelligence and reasoning in order to intelligently handle these null values. So again, vehicles, if you ask ChatGPT what a Silverado is, it knows that's a Chevrolet. That's essentially the concept we're going for here. And so for all of these rows, it's going to identify a column that can essentially act as a predictor for the null value we're trying to handle. And with its intelligent reasoning, it can determine a Silverado is a Chevrolet and an LSV8 is a Lincoln. And here's a good one to point out. So we have 2 nulls here. Why is that? So these 2 were null originally. And of all the features we have remaining to look at, none of them are great predictors of what the brand or the model could be. So we only have year, mileage, fuel type, all of these, none of them you can really determine the brand from. And like rows like that where we can't really make a good prediction, a good confident prediction of what we can put there, we want to leave those null.
But as you can also see, if you just go back there, right? if you were to look at these two rows, I mean, this row in particular, right? While we can't determine the brand and the model, if you look at transmission here, this is null. This is something that we can figure out based on, the information and the values that we have already. And as you can see here in this row, we're still at least able to complete one of those values, which overall reduces the total number of nulls and improves the data set. So the next agent that goes to bat in the serial multi-agent system that we've built is what we like to call the data enrichment feature. Essentially, what we do here is that we will be looking at all the different columns that we have in our data set, and we will have our AI agents suggest new columns to add that would make our data set more granular, better informed, and giving us more features to essentially train on. So as you can see here, we were able to add a few different columns to our data set that we didn't have before, such as car body type, the horsepower, and the country of manufacturer, and whether or not the vehicle is luxury or not. And as you can see, we're able to determine some of these features based on information that we already have. And the language model is able to handle this very well, has enough knowledge to do this. For instance, the car body type of a hatchback, this is something that we can determine just knowing the model of a car. A Mini Cooper S base is a hatchback. Another example is horsepower here. And this one's pretty interesting because in the engine, right, we have all of these values here, right, in total, but we know that this 172 is really just the horsepower. So we're able to extract this certain value and make it a column of its own, ultimately making this a more granular data set, contributing to a better machine learning model. The next agent that goes to operate in our system is what we like to call the intelligent value consolidation agent. So the fact of life in most data sets that you have as a machine learning engineer is that oftentimes you'll have synonymous values like Chevy and Chevrolet that really mean the same thing, but they're treated as two separate entities by your machine learning model, which harms the performance of it overall. However, what we've built is a system here that essentially recognizes all of these synonymous mappings, different instances where we have Chevy and Chevrolet, or maybe, Ford F-150 or a Ford. These all mean the same thing, but they're treated as separate entities. So what we do is construct all of these mappings intelligently and resolve them to the most canonical value. So as you can see, we have Chevrolet here, and another instance of Chevrolet. But in the second page here, we have the brand listed as Chevy. So after this agent gets executed, what we end up noticing is that if we were to go back to that second page, that value gets resolved to Chevrolet as opposed to Chevy, thus thereby giving us more intelligent value consolidation.
And so what we've done now is we've taken the base data set we started with and the refined PureML data set, and we've passed that through an AutoML process using XGBoost to train real machine learning models. And what this does is provides a metric to validate the improvements that we made to the data set. So we have the R squared for the original data set, the machine learning model, and the R squared for the one that we made the improvements to. And as we see, we had improvements. And so the big challenge now that we're trying to tackle is using strategies to make these improvements that work across any data set. So that's what it's a big challenge, and it's something that we have to take a lot of things into consideration. We can't rely completely on the agent's own general knowledge because, like something like cars, an agent, ChatGPT, it's going to know a lot about that. But when we get into more highly specified data sets, that's where it becomes a big problem of we can't rely too much on just intelligence. We have to look more at just individual features of the data set itself.
As Johann mentioned, we are planning to go live in January. Right now, we're currently building out some new features. We're trying to make this more solid, making it work across any data set. If you're interested in our project at all and have a use case that you might be interested in or would like to work with us, you can find us on pureml.io. We also have an X account and a LinkedIn. We'd love to have a conversation with you. And if you might be potentially interested in investing in our project, we'd love to hear about that too.
And we have an intake form on the website if you're looking to test this product out. We'd love to get some testers, so please hit us up.
Yeah, thank you so much for your guys' time.
Thanks, everyone. I'd love to take questions if everyone has any. Thank you.
data sets, right? Because I myself had to handle ETL issues with a web scraping process from a website, and then having to myself had to handle the standardization of missing values, and then modeling wise, creating myself the linear regression model, right? So in that sense, what are you guys hypothesizing to do to be able to get your machine learning infrastructure to have the dynamism to be able to, you know, do that, to do the ETL by itself? Or are you guys planning to be humans in the loop in the process of being able to standardize the data?
Yeah, so part of what we're coding up right now is to make a lot of our transactions have human in the loop layers. This, allows for more controllability from the user's perspective. They can really interact with the different columns of the features that we're trying to add or fix, right? And just by thereby having that more user controllability, we're leaving less up to our AI system, and allowing for us to optimize results in some ways like that.
And going back to your question about how do we make this like essentially robust enough to work across like essentially do ETL for like any data set. What we're really focusing on right now is again strategies that aren't relying on the context of the data sets. When you're thinking about context, then you have to rely on the intelligence of the agent, you have to rely on the information you have, and maybe your data set, maybe the metadata is bad, maybe the columns aren't very descriptive of your data. So like things like this here, like where we can take a string value of this engine field, a categorical feature, and we can pull out a numerical value from that. That's something that's going to work across any data set because it's purely just like you have a categorical variable, we can pull a number out of that and provide a numerical representation to the ML framework. It's things like that. We have a lot of strategies in mind right now that we're trying to implement. Like that stuff, it's gonna like that's the core right here. It's because it works with any data set. It's not really considering what the data set is. It's more focusing on like categorical to numerical transformations.
And beyond opportunities to take the existing data set that you have and being able to make, transformations in the realm of data pre-processing to just make it better, like, extracting numbers from a string like Johann was just talking about, or extracting categories from a string. Another thing that we've thought a lot about is RAG as well. Chances are for like, take this example, right? If somebody is doing a lot of ML model building off of cars, chances are that they have a lot of knowledge base related to cars, a bunch of manuals, whatever it may be, things that could ultimately, be providing information to guide you in building a better data set or something like that. So, if we were able to allow a user to upload their vast corpus and knowledge base pertaining to their data set that they're working with, that would, give the language model and ultimately our agents a better mechanism for being able to add new features and fill in missing values and consolidate values, just based on user-assisted information like that, and having better context specific to the use case. Any other questions?
It was a good talk. Thank you very much.
Thank you guys for your time. PureML.io.
Yeah. Awesome. Our next speaker's on here also, right?
Yeah.
Okay. Cool. Our next speaker is also a remote speaker, and it's going to be Joe Guzman, who's going to talk to us about identifying the risks of space debris. So
Hi, how are you?
Let me switch. Let's see. Let me switch your.
How do you hear me?
Pinned user here for everyone.
Hi, how do you hear me, Jeremy?
You have to show us.
Fantastic, fantastic. Hi, my name is Joe Guzman. I'm founder of a company called Space Cowboy ADR. We're a company that's developing the technology to actually remove space debris from low Earth orbit. And part of the problem with this business model is there's really no market right now. And one of the reasons why there's no market is because customers don't understand the risk picture that they're operating in. Right now, there's about 35,000 pieces of trackable space debris that are being tracked every day by our U.S. Space Force and shared with our with the commercial partners. But there's also about 1 million pieces of unaccounted for debris that are still lethal to satellites in low Earth orbit. And we're trying to inform our customers about that risk because those are the those are the target pieces of debris that Space Cowboy wants to remove from orbit. So in order to explore how we can provide some value to our future customers now before we have satellites in orbit that can collect data and remove pieces of debris, we needed to find a way to provide value with existing data. And so that led me to the Austin Python meetup group, where I was fortunate enough to meet Jacob, and we teamed up on this project, and I'll share it right now. So we called this project Space Debris Risk Analysis Tool. Again, Jacob Barhock teamed up with me on this. And the problem, like I kind of described earlier, was that relatively little data exists about orbital locations of medium-sized debris. And this debris, again, is between about 1 and 10 centimeters in size. Because it's so small, it's hard to track, and it still carries enough kinetic energy to be lethal or damaging to active satellites. So that represents a significant risk that's not being accounted for right now. And there's really little choices that satellite owner operators have aside from assuming that risk of space debris collision. And even if we were able to, even if we were able to forecast satellite and debris conjunctions, the probabilities of collision are actually low because the data has a lot of errors inside of it. And then aside from conducting collision avoidance maneuvers, that's where the satellite actually conducts maneuvers to navigate around the debris. There's really no other alternatives currently to that practice. That's where Space Cowboy will come in the future and provide that active debris removal service to them. So our solution in the short run is to create a synthetic catalog of satellites that represent pieces of lethal but non-trackable medium-sized debris in a similar distribution to what we know as the distribution of tracked objects. And then the challenge is to take those synthetic satellites and propagate their positions out into the future, creating what's called ephemeris or ephemerides for over the next 24 hours in this case. And then use the locations of those satellites to predict where close approaches between either two satellites or a satellite and a piece of debris, or even two debris have close approaches, and those are what we call conjunctions. And so our going in hypothesis is that as we increase the number of satellites in the catalog and continue to run these conjunction assessments, that there will be a higher incidence of close approaches with the addition of this synthetic satellite data. And then additionally, some orbital inclinations, and this is the inclination of an orbit, is the angle at which the orbital plane makes with the equatorial plane, so that it kind of describes where the orbit is actually circling, or circumnavigating the Earth. In an inclination of 0 degrees, it would be the equatorial plane. And if a satellite had an inclination of 90 degrees, it would be straight up and down from pole to pole. So that kind of gives you what we're trying to do is identify inclinations that have the most that carry the most lethal or dangerous debris that are threatening our customers. So the good news is that there is a source for data that we can go to, and we've entered into a data sharing agreement with the U.S. Space Force, and they post their public-facing website, spacetrack.org. You can go there and access all the data that they provide at the unclassified level. So we are essentially pulling the U.S. Space Force satellite catalog. That's a SATCAT. It essentially tells you information about the pieces that they're tracking, what they're named, who owns them, how large they are, and things like that. And then they also post satellite timestamp locations and orbital data, and those data are called 3-line element sets, and it essentially gives you all the information you need to understand where the satellite is with respect to the Earth and how its orbit is shaped, and then how the satellite propagates over time. So we knew that we were going to have to find a couple of subroutines, a satellite propagator, and we'll get into that in a minute with Jacob in the technical discussion. But we wanted to be able to compare these satellite locations at each time step and identify these close approaches. This routine is typically called a conjunction assessment. At this point, I'd like to hand it over to my partner, Jacob Barhock, for him to continue on with the brief, with the technical side.
Okay, so it's a Python meetup, so I'll tell you about some Python, but first some pseudocode, what's going on. So we're trying to assess what happens within, let's say, 10,000, 40,000, or 1 million objects in space that are moving all around, and we're trying to figure out how close they are to each other. So the pseudocode is first load the data, then we generate the fake satellites, because some of the satellites are not here yet, or they are here but are not tracked currently. So we want to get to the point that in future that we'll have many more satellites, and therefore we generate synthetic satellites that are kind of not there yet, or they may be there but they are not tracked. And we want to see the actual impact of all of those satellites and how much it affects everything. So we generate those. Then for each time step, and we're trying to project what happens within the next day. For each time step, let's say a few seconds forward, or a second, or maybe a fraction of a second, we propagate the satellites to find their positions in space. So now you have 10,000 or 40,000 or 1 million satellites in space, and you're trying to see how close they are to each other. When they're too close, this means there might be a collision. Okay? So we also have to miscalculate, filter out miscalculated objects, because sometimes the subroutines cannot calculate, and sometimes they're even like the data itself has some noise in it that we need to remove. I won't go into details, but we do this. And then we calculate the nearest neighbor. And then we generate the final report that tells us how close objects were at any points in time and space. Basically, all the things that are as close as possible to collisions. So I'm going to show you again what happens. Can you move to the next slide? Now, we do have some computational issues. And this is where Python steps in, because it gives us a plethora of tools to actually solve that problem. But let's look at the problem. What's the complexity of finding, let's say, 1 million objects, and you have to find all of the closest objects within 1 million objects to themselves? Think about it. Each object is, of course, is closest to itself, but then what's the next one, or the next one after that? This problem is actually, if you do it the brute force way or without thinking, like 2 for loops for each object, find all the other objects, calculate space, it takes you O(n) squared complexity. This is inefficient, because for a million objects, it will take forever. even if you have a lot of computing power. So what we're doing, we're looking only at the nearest neighbors to detect collisions, and we use the scikit-learn implementation of a KD tree to find the nearest neighbors, which drops us to O n log n complexity. I forgot it's not only n squared, it's actually times t, because you'd have to do it for each time step. Because you remember, we propagate the satellites and find out which the time are in space, and each time we calculate all the nearest ones at the same time. So the complexity with the KD3 is O n log n times t. However, remember, t is embarrassingly parallel. Each time we have a time step, then we only look at the satellites at that time step. So we can actually go and look at each one of those separate, and we can process those in multiple machines or multiple CPUs or whatever. Again, Python to the rescue. We have the Dust library that allows us to take and spread all this computation. By the way, there are, if you are really into it, there are maybe even better ways to reduce the complexity. However, from an engineering point of view, the easiest way and the best way to make the program writable is actually use Dust to spread the computation apart. Then computing power is cheap. Then you can go on the cloud, or you have a machine with many cores and you can compute things. So Python allows us to do this fairly easily. There are several things on the way that I'm not going into details how we did. There are like several obstacles we have to overcome, but this is the general idea. Let's go to the next slide. Let me show you some results. So what we did is we compared three options. One of them, there were 10,000 satellites at a certain point in time, actually 10,828, about 10K. And we are looking at two satellites that will say, let's say we have clients of two satellites, we chose just two. And we want to know which other objects getting as close to them as possible. So in our case, it's like Iconos 2 and ISS Zyra. We have a start date, and we want to know in intervals of 10 seconds, and for 8,000 steps, meaning it's approximately 1 day, more or less, we want to know what are the closest collisions. When we run this and we find out that the closest collision is about 11 kilometers for those two satellites, for all satellites, if we took it the 10K option. And we can actually spit out which other objects are closest. So in our case, Iconos 2 is closest to Starlink 377, which is some sort of satellite. However, this computation takes us about 16 minutes on 32 core, actually 32 thread machines, 16 cores, 32 cores, because it's all parallelized. So it takes us 16 minutes to calculate a day of computation for 10,000. However, now we have to calculate it for 40,000, which is more or less the number of objects that are here today, more or less, according to Joe. So we just made 3 synthetic copies of each satellite. Of course, they're slightly different. I won't go into details what we did there, but it's pretty smart. And we find out that the distance now, after 1 hour of computation, this is how much like it takes for a computer, it now reduces to 10.17 kilometers, and some fake satellite we created becomes closest to Iconos 2. However, then we want to do what happens with 1 million. Now I'm running it again on the same machine. It took me 7 hours to calculate that the closest object with a million object would be 1.476 kilometers. Now notice, we're only looking at 2 objects. Think about how many collisions will there be at all of those. We can actually compute this in a reasonable time. I didn't show it here, but it's possible. And here, actually, Zyra is becoming very close to some fake object. This is only the closest, but I can actually show more. At this point, you can see that the more satellites there will be, and Joe will move to the next slide if it's okay. We have many non-tracked objects today, and there'll be more and more, because each time there's a collision, there's more debris. And there'll be more and more collisions the more things accelerate, because first, people launch more satellites. B, there are more collisions the more satellites there are, so everything kind of accelerates, and you have more debris, and then you have more debris, you have more collisions, more debris, so it kind of will accelerate. And in the future, you just have a crowded space. So you need a service like Joe is operating on. So in the future, we show using Python and a lot of smart computation, a lot of Python tools that it's fast that this kind of business is viable. And hopefully we'll go with this, and hopefully Joe will continue and say what the next steps that he's going to plan to do this. But um, basically, we need Space Cowboy. This is my understanding out of all the computations that I did. So, Joe, do you want to say add something to it?
Absolutely. Let me pull down the slideshow here. Thanks, Jacob, for that. And yeah, so what we kind of described here is known already, or at least has been described by a NASA scientist called Donald Kessler um, back in the 90s, and he forecasted that if we didn't do something about space debris, that there would be a cascading and exponential growth of more and more space debris until such a point where it would limit our ability to actually put things in orbit and actually utilize satellite technology in the future. And this is a very big problem, because right now the Global Economic Forum is forecasting the space industry to reach $1.8 trillion by 2035. However, if we don't put some kind of a management scheme to reduce the risk of satellite collisions with debris, then we're going to find ourselves wasting a lot of money in space. And so this is a very infrastructure intensive type kind of activity that we're after, that really sets the stage for the growth of that space economy. So it's very important work, and I'm just really excited to get involved with the Python community to help me generate some data that shows this empirically. And now we're open for questions. Thanks.
Yeah, I'm going to be the pedantic person here. But I do have a question. So how do satellite specialists currently solve the issue? You can I hear me, Jacob? Okay.
I'll repeat it.
Or do I go?
I'll go ahead and repeat
Okay.
it.
So how do current satellite specialists solve the issue of debris? Do they just do it on the accident per basis? Do they just evade it? Or because I mean, if you're developing the models, then they must not have the models. That's the reason that you're creating this.
How do okay.
So yeah, I'll answer the question. Right now, there are models and propagators for the tracked objects that we know. So, like I said earlier, there's about and Jacob showed there's about 10,800 satellites orbiting today, and then roughly about 35,000 tracked pieces of space debris. So what we can do right now is really run the conjunction assessment for those tracked objects. That's why there's a big data gap right now for the locations of the smaller items of debris, and that's one of the pieces that we're going into space to actually be able to find those items, because it's difficult to track them with existing technologies from the terrestrial surface of the Earth out to between 400 and 1,200 kilometers away. They just can't get a high enough accuracy data set that enables us to do collision avoidance conjunction analysis. And so really tightening up the quality of data about small pieces of debris will help us to, number one, identify when there's risk to our customer satellites,
what Joe was saying? How much did you hear from what Joe was saying? Okay.
I think
Where,
I
where's
think I
your-
got everything in right before, but yeah, we can. Short answer is that we can run the collision. We can run the conjunction assessment with the 45,000 or so known and tracked objects, but in order to overcome the risk of the 1 million pieces of lethal but non-trackable debris, really the only option is to build margin into the satellite so that it has additional power. So, we're essentially launching, let's say, if you need 10 square meters of solar panels for power to power your satellite, you have to launch with, some margin. So let's say 15, and every time you build margin into the satellite, you have to launch that at a cost of about $10,000 per kilogram into LEO. And so, margin costs you money. And so what you have is trying to reduce risk by over engineering the spacecraft. And what we can do, if we have a better understanding of the risk picture, we can allow people to engineer to the mission and not have to over engineer. We can remove debris at a lower cost point than our customers can navigate around it. And that's the value proposition of Space Cowboy.
And we can do actually the code we wrote here can be actually very easily adapted because it already is propagating stuff and it's efficient. You can make it such to spread it across as many computers as you want or as many CPUs very cheaply and get the answer very quickly. And do it as many times as you want. Computing power is cheap.
I have not. Jacob, have you had that idea?
It doesn't matter much. The mechanism is more or less the same. GPUs have more parallelization. The code currently, yes, you can run things on GPU if you really want to, but then you have to write everything in CUDA, unless you have a library that does this for you as well already. So the newest, and eventually you get limited by GPU size, like memory size and stuff like this, which is probably not a problem with the sizes that we're talking about. But yes, you can probably add more acceleration, but it's already efficient enough. Think about it. It's like you calculate an entire day in 16 hours and 32 cores, just give it more cores. Cores are easy today, CPU cores. Yes, you can do it on GPU if you really want to, but then again, you have to write more software. You have to actually go and find the KD tree analysis that runs on a GPU that does this efficiently. And probably there is one, you just have to write more, and it's no longer Python at that point, unless there's a Python library I'm not familiar with. Do you know one that does KD tree, ball tree, or some other thing that is on GPU immediately? Anyone? But I can tell you one more thing. Databases today do the same thing with nearest neighbor search. Whenever you have a RAG system in AI, it's the same nearest neighbor. So if the AI people implemented this on GPU already, which I assume there might be because a lot of those systems actually run on GPU, then maybe there's a way to actually go there and extract some of those things and make it more efficient. I haven't looked at it, but sure, it's a good idea. I like the idea. Perhaps it's the next stage. But then again, I told you there are even better ways to do this, even in less complexity. If you think about the problem, I won't go into details. But if you're like really a guy who deals with math and likes all those complexity stuff, there is a way to actually make it even more efficient. But let's not go there. It becomes complex code, and then from an engineering point of view, complex code has its own problems. I actually talked to a friend of mine about that. He had some good ideas, but eventually the engineering problem. You don't want complex code because it's unmaintainable. You cannot deploy it as easily and stuff like that. So there are trade-offs. Did I answer the question?
Yeah, we're really treading new ground right now. The code that the Space Force used to do these calculations now is actually based on Fortran, so it's literally like 50 years old. And um, so even contemplating taking that computational data and using Python or some other computer language is really new concepts. And I've already lined up a potential customer who does work for the Space Force and NASA. And what we want to do is present this to them and see, and essentially ask them if this is an improvement, if using Jacob's parallel processing is an improvement over the way they do business today.
I agree. Yeah. Grace Hopper is one example. There are other examples of NVIDIA chips you can put it all together. I agree. However, guys, this becomes an engineering thing. The code to write this, what I did, had already some issues that you have to solve. I'm not even going to talk about those. You add more complexity with the hardware, code becomes more complex, less maintainable, less debuggable, less many other things. So there's a trade-off. Currently, it's good enough. Sure, there'll be funding and need to do it faster. Sure, GPUs. There might be, and I told you there might be even faster ways to do it. I won't go into details here because I'm giving too much anyway. And we want our customer to be engaged, let's say it like this. We know how to make those things better if there is a need. And by the way, if Joe thinks this video is good enough, maybe we'll just post a video to the customer and see how they like what is going on here. And then we'll come back to you and tell you, oh, the San Diego Python meetup helped us. Hopefully it will happen.
Mine? Sure. So I have a BS in electrical engineering from U.S. Military Academy at West Point. I got an MBA, Cameron University, and a Master's of Science in Space Systems Management and Operations, and a Master's of Arts in National Security Studies from the Naval War College. And I spent 26 years in the Army with about 20 years doing space operations, execution and planning.
He's the domain expert. I'm just a computer guy. I have degrees in computer science and mechanical engineering, but I'm a computational disease modeler. I use a lot of computing power, and I actually gave you a talk in San Diego Meetup once again, how I use a lot of computing power to figure out COVID and diabetes and some other things. So I use a lot of parallelization, and here I have a machine now running COVID simulation near me with many cores that takes weeks. And if I have a cloud, I can run it on multiple processors. So I'm used to doing those computational things. The minute Joe told me the problem, I figured out exactly, oh yeah, it's I know how to solve it because I'm doing the same thing for diseases.
Yeah, it was very interesting because really my initial question for Jacob was about generating synthetic data based on a distribution of known data. So the assumption is that the distribution of the 1 million objects roughly parallels the distribution of the known objects. And so we just wanted to expand that population, put more of these fake satellites in orbit, and then be able to run the conjunction assessment across the entire population. And kind of when we started working on this, Jacob was, he was picking it up as I was laying it down, and I'm just so thankful he was able to. Really, it only took about 4 to 5 days for him to turn around a prototype, which is amazing.
Don't tell them. It took
and-
years.
And oh, by the way, he was also getting shot at over there in Israel.
Yeah, I'm in Israel now, guys. We're getting shot at all the time by missiles and rockets and drones or whatever. Anyway, but yeah, in diseases you do the same thing. Since you don't have access to the population, you have to generate fake populations that match the distributions, which is exactly what the problem is now. And now you have the problem of too many things. Now you have to parallelize all the simulations. So it was easy for me because I was been doing it for years. I knew all the technology. For me, just pick up the Lego and do this. And this was easy. But yeah, now the AI, you're correct. It's like maybe it's the next future, doing it on GPUs. Well, if the libraries don't exist now, they'll exist in no time after you talked about it, and then someone will implement it. So
Sure. Yeah, absolutely. The yeah, so so, um technically I think it's feasible. You would have to be in a you'd have to be in the same orbital inclination and orbit as the satellite itself. But one of the things about when that's called the situation you're talking about is called debris shedding. So when debris, falls off of a satellite for one reason or another, a lot of times they have malfunctions or anomalies on board, like pressurization of a fuel tank or something like that will cause a breakup. And if you have a active debris remediation or ADR servicer in roughly the same orbit as that satellite, yes, you could come up behind it and collect that debris off the shedding. Um, it's really a different situation because in that case, what you're doing is cleaning up a mess that was left by a satellite company, and that's really relieving them of liability risk for the damage that that debris could cause to other operators in space. And the liability convention of the Outer Space Treaty of 1967 really hangs the liability for that debris on the nation that launched the satellite. The the Outer Space Treaty doesn't recognize commercial companies as players in space. It really only recognizes nations. And so it's really up to the nation under which that satellite is flagged to regulate the operations of that company so that they pick up debris. And there was one fairly recent example where Dish Network left a dead satellite too close to the geostationary belt. And the geo belt is really, it's like prime real estate in space at a 0-degree inclination, about 36,000 kilometers away from the surface of the Earth. And this one orbit is essentially on the equator, so it has good access to both north and south hemispheres, and so for that reason, it's very valuable. So this U.S. company left a satellite in the geo belt dead, and so the FCC, Federal Communications Commission, levied a fine, the first one of its kind, against the commercial space operator leaving debris in that orbit. And kind of the going rule of thumb right now is the U.S. government is asking commercial satellite owner operators to be able to remove their satellites from operational orbits within 5 years of them, becoming inoperable. And so, that's, we'd like to see that number come down even further, that time frame. But it's for exactly that reason. The longer you leave a dead satellite in orbit, the more opportunity it has to get hit and then shed or break up into other pieces. And so that's definitely the thing that we're trying to prevent wholeheartedly. There's really two camps of active debris remediation. So Space Cowboy really goes after the small pieces so that we can prevent collisions with larger satellites from those small pieces. And then there's another group of active debris remediation companies that are going after the large mass objects like derelict satellites and rocket bodies and upper stages that are out in orbit. And those pieces of debris, if hit, would create much more pieces. And so the community has really kind of put the priority on removing large mass objects over the ability to clean up the mess of small pieces. So there's a little bit of an imbalance right now. And but it's my firm belief that collisions are going to happen in space regardless of whether we want them to or not. Regardless of whatever policies and regulations are put in, there's always going to be collisions, just like there are on the highway. Nobody wants to collide, but it happens. And when it happens, you have to have capabilities to go clean up the mess so that we can restore, the free flow of traffic on the highway. And that's what Space Cowboy is all about. Really appreciate y'all's attention, and thanks for all the great questions. And thanks for Jacob for being up and about, even though he's in a combat zone.
Thank you. All right. I'm gonna go ahead and take the last.
So we're just doing you, right?
Yeah.
Okay. Well, I'll let you do your own introduction.
That's okay. All right. So I'm going to go ahead and kill the feed since I'm already here. And that way I can take a look at my screen. I've got some talk notes. Let's see. First of all, I want to thank Space Cowboy and PureML for giving their talks tonight. And let's see. We always have interesting speakers, and would like to welcome you if you're, let's say, first time coming. If you, we hope that you're interested in giving a talk. Tonight, I'm going to be talking about what are some of the projects that you could be doing over the next few months, because let's see, we're not going to have our normal talk topics next month, so we're going to have pizza. So this is the last talk of the entire year. So let's see, I want to thank you very much for coming. I hope you've gained a lot from various speakers who have spoken throughout this year. And let's see, I'm going to be giving you some ideas on what you can do over Christmas break. Let's see, Thanksgiving, maybe you'll have some extra time during Thanksgiving. This is the time whenever strange projects get all sorts of pull requests. So let's see, what should you pitch in with? So I'm going to be giving an overview of niche topics that haven't been covered in a while to get some creative juices flowing. Let's see, typically Python is great at data analysis types talks. Let's see, machine learning, web development, automation or scripting. Please don't say that Python is only for scripting. Let's see, LLM integration and software testing. These are kind of the fundamental pieces, the building blocks under which we can do everything interesting. And so they need some love. If you're interested in data analysis, you can use something like Pandas. Pandas is like the granddaddy of all these data analysis libraries. If you want to speed up some of these operations, you can use something like Numba. Numba can be able to take your existing code and be able to run it on things like CUDA, let's say, or NVIDIA GPUs, that type of thing. Machine learning topics, NLTK, GenSim, PyTorch, and Keras. These are machine learning topics. NLTKs will help you to figure out what kind of parts of speech that you would like. GenSim, it will help you to figure out, is this a positive or a negative statement about your company? PyTorch and Keras are both used for machine learning type questions. So web development, Django is, let's see, the large web development library. It, let's see, Flask is the fast one. It has, let's see, Django has lots of middleware that can help you out with your projects, where Flask, you have to build those pieces yourself, or let's see, add on those pieces yourself. So there's other ones, Flask, Fast API. This is typical web development workflows. So automation or scripting, you can do things like pipelines in Google and AWS and Azure. LLM integration. This has been a popular topic as of late. So OpenAI, Claude by Anthropic, Llama 3, Mistral. Those are, the last two are smaller models that you can run locally on your own computer. Software testing. These are things like PyTest, or if you're doing testing for websites, you can do Selenium or Playwright. So, but those are kind of the foundations. And if you want to see how they fit together, take a look at outside. There's a poster. It'll have the different layers of Python development as far as data science goes. So libraries and how they stack on top of each other. Over by the pizza. That is by design. So, yeah, let's see. I don't like the whole death by PowerPoint and let's see, reading. If people take a look at my notes, and then it's okay. So we've seen some topics this year talking about some niche topics, things like game programming with Pygame. Let's see, bioinformatics libraries. If you can do a substring search for ACGT, for example, in a large string, you can do some bioinformatics. Biologists are looking for you. So there's cheminformatics. Let's see. There's APIs and command line tools that you can integrate with for chemistry. And let's see, find out about a library called Pikachu. I kid you not. Let's say it's a Python-based informatics kit for chemical or analyzing chemical units. So if you wanted to do graphics programming, you can get involved with Blender, Maya, let's see. And if you're looking for 2D stuff, there's Photoshop can be Frankensteined with something called Windows or Win32com. I wouldn't suggest it. I would go with, let's say, the GNU image manipulation program. It's called GIMP. I don't know why, but it's coming out with a new version after like 20 years. This is a very old program, but it's getting an update. So it's got a release candidate. Check it out. Find out what their Python integrations are now. So maybe if you're at home with your family this Thanksgiving, you can be thinking about genealogy software. It's one of those topics that you get with the family, find out all kinds of analytics about your family. So that's the Gramps software is written with Python. So if you want to do astronomy, there's AstroPy. These are programs to take a look at the stars and NASA data. So if you want to do quantum computing, chemistry, physics, you can get involved with libraries like Qiskit. Google uses something called QSIM and PennyLane. PennyLane is how you can be able to build a architecture that works on several different types of quantum computers. There's everyday tasks, things like integrating with APIs. Right now, San Diego is putting out data that, let's see, on data.sandiego.gov, you can connect with their APIs and be able to download San Diego's data, things like crime rates and water quality and health department data, traffic collisions, pothole repair, street sweeping schedules. I mean, they've got all sorts of things. you can stay on top of your city's infrastructure with topics that you care about. And if you don't really want to get involved with the city, you can do it with the national government on data.gov. They have APIs for all the regular things like energy and health and land use and US Census data. But they also have tiger shark distribution. Find out where the tiger sharks are. Let's see, some weird topics. They've got 301,655 different data sets that you can tie in. So it's not for lack of data that you can't figure out, something to do with the time over this Christmas. So let's see, they have Germplasm Resource Information Network. Find out what that is. I haven't the slightest. No, let's see. Let's see, as well as integrating with other APIs that are the norms, maps, restaurants. There's an open banking movement that you can get involved with. Let's see, NOAA APIs. Nobody knows that you don't need to connect to your local news resources to be able to get the weather. You can get it yourself. Just right off of NOAA's website, give it a latitude and longitude, and you can find out what your weather is. Let's see, NOAA is the one that supplies CNN, Fox, NBC, let's see, all the big news networks with their news. Let's see, if you don't want to focus on satellites focusing down on Earth, how about focusing out in space? NASA has an API. You can get huge images that are being able to be pulled down from that. So are there other APIs that you know of that you would like to tout? Let's see. Baseball API. Dapper? Tell us about Dapper. Dapper.io. Okay.
So it allows you to write in any language against any cloud provider, anything.
Write in any language against any cloud provider. That one's a good one. Pardon me. Take notes.
So the idea being instead of downloading the API for say very like an AWS database service, you can write it in something where it doesn't have to know that, but still be able to use it. So if you decide to change cloud providers, your code doesn't have to change. You just have to retest it.
Okay. You can change providers without, let's see, much more easier. Cloud agnostic, thank you. Let's see, other APIs or tools that you use that you want to be able to highlight?
Yahoo Finance.
Yahoo Finance? Be able to get stocks or stock information. Does it have options? Anyway, I'll find this out later. So.
You mean options means the derivatives for trading?
Derivatives? Yeah.
Trading derivatives. Is that what you're asking for options?
Yeah.
Oh, they do have them.
They do have options.
Option tables, correct?
Okay,
Yeah,
cool.
the tables of options.
All right. Let's see. Other things are the robotics operating system has Python APIs, so you can build robots. PyAuto GUI. Let's see. You can automate your own desktop. So kind of strange whenever you watch your mouse go all over the screen and start clicking on things. Like the modern day Ouija board. Anyway. All right. So the last part, let's see. It's the season to also start thinking about end of year giving. These are, let's see, you can give to these organizations, 501c3 organizations is what I'm going to mention here. Let's see, you can do it for a tax write-off to things like the Python Software Foundation. This is kind of the core of what makes Python possible. Django Software Foundation, if you want to be able to help out those who are building websites. NumFocus, they do a lot of data science-based tools, so you can help out with financial resources in order to help Generally, what a lot of these go to is interns to help fix bugs. And so it teaches the interns, it fixes the bugs. So it will help, or it's the, these are the foundations that help float all boats, including the Apache Software Foundation. So, and the last one being EFF.org, the Electronic Frontier Foundation. Let's see, there's some strangeness going on. Let's see, the mainstream media has been taken over by the satirical news headlines of The Onion lately. Let's see, there's been some strange, strange changes in politics, and the Electronic Frontier Foundation is a group that helps keep our, collective sanity in politics. So they do things like they make sure that we have the ability to make changes to the phones that we bought, or hey, we can add ourselves to a do not call list for robocalls. We're going to be inundated by the onslaught of AI robocalls otherwise. Let's see. So Electronic Frontier Foundation makes sure that these policies can be implemented and carried out. So they're a group of lawyers that help bring about these policies. So whenever you hear things like Notepad goes AI, let's see, Microsoft Notepad, it was supposed to be a simple app, but they decided to bring AI in it. Anyway, this open source software needs to be defended too. So anyway. Yes. No. The URL, the .onion sites, that's Tor based. Now this is, let's see, The Onion is a satirical news website. They have some funny stories every once in a while. It's great. So watch the YouTube channel. It's got some amazing, I'm not going to go into any one of them here. It's going to be an interesting one. Let's see. And yes. Let's see. There's Qiskit, there's Penny Lane, and Q. There's the Google one. Think about it in just a moment. QSIM, QSIM. So Google is QSIM. So Qiskit is by IBM. It's probably most well known at this point. They kind of launched that one first. So Penny Lane is trying to figure out how to make it possible to program for different architectures at the same time. So.
Yeah, they figured it out. So you wouldn't have to use a Qiskit because you could write it in Python for really any hardware, whether it's on the Azure Quantum or the AWS bracket or the Google one.
All right. Well, enjoy your end of the year, and let's see. Hope to see everybody next year at San Diego Python. Yeah, you too. Yeah. Any other questions? Let's see. But, all right.
So I searched for a San Diego Python user group and then recommend register or something, or because we just crashed with the help of one.
Yeah, just show up.
We met him somewhere else and he said, "Come show up here."
Yeah, just show up. Let's see. There's
Meetup.com and then search Python San Diego.
Okay,
You'll be able to find them.
the RSVP is let's see, is not necessary. So
It does help us get how many pizzas to buy, though.
Yeah,
yes.
and also, if I join, I know the dates and time.
Absolutely.
That's why I have to do the RSVP.
Well, thank you for coming. Thanks to our speakers, and thanks to Qualcomm and Neo4j. So we'll see you hopefully at Regent's Pizzeria. Otherwise, January, same time, fourth Thursday. We'll get it figured out. All right.
So next
Thank
time
you,
we're gonna
everybody.
do it at UTC.
Yeah, just because the fourth Thursday is going to be like too close to Christmas. Good.
Who is doing the AI LLM project?
PureML.
PureML.
No, the people before the presentation who were saying like they needed
Oh, Danielle.
Danielle.
Give me your email address and I can connect you with her.
Yeah, send it to me as well.
Okay.
You already sent the other thing. I'll also connect.
Yes, already sent. So
Okay, so we're good. I'll wait for her to respond.
yeah.